Today our topic is special right triangles. So our learning target is how can I use the relationships among the sides in the special right triangles. So the first special right triangle is a 45 degree, 45 degree, 90 degree triangle. And we just call it 45, 45, 90 triangle. It is an isosceles right triangle that can be formed by cutting a square in half. So if you look here, square is cut in half. Square, all the side lengths are the same. And isosceles means that they have to have two sides congruent. And then 90 degrees, cut a 90 degree angle in half, you get 45 degrees and 45 degrees. So our theorem for our 45, 45, 90 triangle is that the hypotenuse is the square root of 2 times as long as each leg. So right here, this is something really important. You might want to star it, box it, circle it, but that's a good thing to know. Hypotenuse equals the leg times the square root of 2. So if you look here, our legs are our x's. They're the sides next to the right angle. Then across from the right angle is the hypotenuse, which is the square root of 2 times your leg. So example 1, find the hypotenuse of the triangle. Well, the hypotenuse is the side across from the right angle. Check to make sure it's a 45 degree 90 triangle. Well, we have the 90 degree, we have 145, which means the other angle is 45 degrees. So we can use our theorem. This is a leg. Our hypotenuse is unknown, so I'm going to call it x. So I'm going to set up using our equation. Hypotenuse equals leg times the square root of 2. It's right here. Then plug in the variables. Hypotenuse, I said, was x, equals the leg, which is 8, times the square root of 2. So our hypotenuse is 8 times the square root of 2. It's as simplified as it goes. Second example, find the lengths of the legs of the triangle. All right, so first off, we need to make sure we have a 45 degree, 90 degree triangle. If you look, our legs are the same, which means we have an isosceles right triangle, and an isosceles right triangle is a 45 degree, 90 degree triangle. So we can use our theorem. And the theorem states that the hypotenuse equals the leg times the square root of 2. The x's are our legs. The 5 square root 2 is our hypotenuse, so plug in the pieces. 5 square root 2 equals x times the square root of 2. We want to get x all by itself, so we want to divide by the square root of 2. On both sides. Square root of 2 cancels here, leaving us with x. Square root of 2 cancels here, leaving us with 5. So the length of our leg is 5. Our second special triangle is a 30, 60, 90 triangle. And this triangle can be formed by dividing an equilateral triangle in half. So equilateral means equal angles, which means all the angles are 60 degrees, and congruent sides. So if you look at the equilateral triangle pictured, we have congruent sides, 2x, 2x, x plus x is 2x, congruent sides, and then all these angles are 60 degrees. Well, this angle is 60, this angle is 60, but we cut this angle in half, which means it's 30 and 30. Then right here we have a 90 degree angle, so now we have a 30, 60, 90 triangle. So that's how it's formed. And our theorem for this is in a 30, 60, 90 triangle, the hypotenuse is twice as long as the shorter leg, and the longer leg is the square root of 3 times as long as the shorter leg. So again, we have some equations that you might want to star, circle, box, however you remember something, highlight it. But these are going to be important to remember. All right, so if we look, the hypotenuse is across from the right angle. Your longer leg is going to be across from the bigger angle. So the 60 is the bigger angle, so this is your longer leg, so I'm just going to call it long. And then across from the 30-degree angle is going to be your shorter leg. So I'm going to call it short. All right, so now let's use this theorem to help us find the values of x and y in our example. So we have a 30, 60, 90 triangle. So I'm just going to start off by labeling short leg, long leg, and hypotenuse. So across from the right angle is my hypotenuse. So I'm going to say hypotenuse. Across from the 60-degree angle is your longer leg. So we're going to call 9 the long leg. And then across from the 30-degree angle is your short leg. So now that we have the pieces labeled, we can set up our equations. Hypotenuse equals 2 times the shorter leg. Well, hypotenuse is y equals 2 times the shorter leg, which is x. Well, we can't do anything more with that, so let's just put a pause there and move on to our second equation for the long leg. So longer leg equals short leg times the square root of 3. Now we can plug in our pieces. Long leg is 9 equals the short leg, which is x, times the square root of 3. We want to get x all by itself, so we have to divide by the square root of 3. X equals 9 over the square root of 3. However, when we're writing our answer, we don't ever want a square root in the denominator. So let's talk about how to rewrite this. 9 over the square root of 3. We want to multiply it by some form of 1. So a form of 1 could be 2 over 2. It could be 7 over 7. It could be negative 5 over negative 5. But we want to multiply it by some form of 1 that gets rid of the square root of 3 on the bottom. So what we're actually going to do is we're going to multiply it by the square root of 3 over the square root of 3. We take the square root in the denominator and make it into a form of 1. Because the square root of 3 divided by the square root of 3 is 1. 9 times the square root of 3 is 9 square root of 3. The square root of 3 times the square root of 3 is the square root of 9, which is 3. So it eliminates that square root. Then we can simplify. 9 divided by 3 is 3, so it's 3 square root 3. So that is actually our value for x, for our short leg. So I'm going to write that right here. 3 square root 3. Now that we have the short leg, our value for x, we can finish solving for our hypotenuse. Hypotenuse is y equals 2 times the short leg, which is 3 square root 3. So y equals 2 times 3 is 6 square root of 3. So that right there is our hypotenuse, 6 square root 3. That's all the notes that I have for you today. Thank you for watching this video, and please subscribe to my YouTube channel.